All right, so again, it says a line passes through this point on the curve, blah, blah, blah. So it tells us that one of the roots are -1. And then it says, suppose that this line has a gradient of m, is tangent to the curve at another point P, whose x-coordinate is alpha. So if it's tangent, this is a cubic, by the way, and we know the other two roots, it must bounce to be a tangent. So if one of the roots is alpha, then the other root is alpha. So now we know the roots are -1, alpha, and alpha of the curve. So we've got this line y equals mx plus b, let's say, or c, whatever it is. If I put those two curves together, the roots, these are the three roots of that equation. So show that the line has this equation. All right, so we can either do that or do y minus y1 is gradient x minus x1, whichever version you'd like to use, but we do know this point lies on it, so I'm going to use that point. So y minus minus 7 is gradient x minus minus 1. So you can see if I expand that out, I get m and then minus 7. So I've got y equals mx plus m minus 7 as my line, straight line that is crossing at x, the cubic, this cubic, at x equals -1, and it bounces, or it hits it and then bounces off at x equals alpha. So show that the cubic equation, whose roots are the x-coordinates, blah, 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 intersects the curve at that point. Okay, so remember this and the cubic are intersecting, or in the case of x equals alpha, bouncing. So tangent to, I think that's a 1. So if we make them equal to each other, we should get that equation. So where they cross or touch is where they're equal to each other. So let's say x cubed minus 3x squared plus 4x plus 1 is equal to mx plus m minus 7. So we've got x cubed minus 3x squared plus, so we're going to have a 4, take away mx, if we put this on the other side as well, and then we're going to have a 1 minus m plus, I'll do it all, 1, take away m minus 7. So if we put all that together, we've got x cubed minus 3x squared, whoops, plus 4 minus mx, plus, so we're going to have a plus 7 here, so 1 plus 7 is 8, and a negative m. Okay, so that's going to be our B, C, D there. So explain why the roots are -1 alpha, and hence find the point. So we know the roots, we've already found the roots to be that, because this was a single root, so this is where they crossed, and then it was tangent at alpha, so it has to be a double root to be tangent at alpha. Okay, now if we use our A, B, C things, so if I use, for example, the sum of roots, we know is negative b on a, which is that, we can definitely find alpha. So we've got 3 plus 1 is 4, 4 divided by 2 is 2. So we know this point P, which we were given up here, is actually 2 something. Now when I put 2 into the cubic, because we don't have the other line yet, because we don't know m, but if I put it into this cubic, we get y equals 8, 4, 3 is 12, 8 and 1. So 16 take away 12, and then plus 1, so we should get y equals 5, so I'll put that there. So 2, 5 is the point where the tangent is. Is that what we're looking for? Hence find the point P. Okay, find the point P, and then find the value of m. So to find m, remember that point P where it bounces has to lie on this equation as well. So let's put 2, 5 into that equation, and we get 5 is equal to 2x's. So we're putting it in here. 2x's plus m minus 7. Why am I saying 2x's? I'm putting 2 in for x, so that'll be m to m There we go, that's better. So we get 3m's, add 7 to the other side, and we get 12. So it looks like m is 4. All right, is that all we had to find? So the value of m, so the value of m is 4. So we're just subbing the point that we know p into that equation as well.